This is JWP, J-Ward Primo Beats, coming to you live from my bedroom. I will be continuing along looking at the manual for SynthEdit. Jump into my desktop and open up the manual. It's under Help, SynthEdit Help. And I believe I've covered most things. Specifically, I'm going to be covering subcontrols for this. So I'm going to make a title screen. So I'll be looking at the manual, specifically the section on subcontrols. If I can find the right button. Alright. So in the manual, under tutorials and reference, we have subcontrols. About subcontrols. Perhaps a quick brief from me. Subcontrols are similar to the standard controls, however, they allow a bit more customizability. The raster graphics can be edited. They have a hint for tooltips, which when you hover your mouse over, and they have a right-click ability, grade, and it goes into their efficiency, so hopefully I can cover all of that. I do need a second. Alright. Subcontrols. Introduction. Subcontrols provide a more customized user interface than standard controls but require more expertise to use efficiently. They provide a lower level access to various visual elements on your control panel. Controls versus subcontrols. Controls. So controls are the ones that I demonstrated earlier. And controls, and we have the slider. This one can be switched to alternate things using the drop-down menu here. And we have the list entry, which are pretty much the basic controls. Before subcontrols, SynthEdit provided only pre-made controls, like the slider control. To understand subcontrols, it is useful to understand how a control works. A slider has several interacting components. Moving the slider updates the numeric text readout and vice versa, so there's a bidirectional connection between the two subcomponents. Your computer typically updates its graphics 60 times per second, yet the control's output is at audio rate signal, typically 44,100 samples per second. There is a rate conversion happening inside the module. The current position of the slider is stored in the patch memory. The slider will move automatically to reflect the current patch. With a traditional slider, the layout of the elements is fixed. With this traditional slider, the layout of the elements is fixed. There's no way, say, to put in a numeric readout at the top. So breaking this down, what it's saying is the original slider, not that slider. This slider cannot, like the text readout, cannot be moved to the top. This isn't a container, this is one static piece, as well as the list entry. So it's also bidirectional, meaning that when I move the slider, it's changing the value here. And the graphics are only updating 60 times a second, whereas the audio coming out is moving at 44,100 samples a second. So however we can't see it, this slider it has its own patch memory, which is here, patch value. But obviously it's not a container, we can't see it. And patch memory generally stores the values. More about that in a moment. It also has its own MIDI or automation. Subcontrols. Before moving on to subcontrols, is there anything else? The current position is stored in patch slider. The traditional slider layout of the elements is fixed. No, that right off the bat. The elements are fixed, meaning it can't move anything around, right? Subcontrols. The purpose of subcontrols is the purpose of subcontrols is to decompose the control into its constituent parts, giving you more flexibility to customize the control. Here's an equivalent subcontrol-based knob. It's built inside a container module. Menu, insert, controls, knob creates a similar one. So we can see here a picture of a knob, which is created using a container and smaller or individual modules that make up the knob itself. You can see here a patch memory, and a text entry, a couple text entries, a conversion module. Here we have the bitmap image, and here is the DSP out, which is going to a float to volts, converting the float value to a volt value, and then it's going out of an IO mod. Now we can pull up that same knob inside SynthEdit under Controls knob. However, I am going to, before doing that, I'm going to cut this stuff out and drop a container. We'll call this subcontrols demonstration. And I'm going to take this name and save as, again, right on my desktop. Probably delete it later. Call this subcontrols demonstration.se1. Now that's saved, and we're going to hold shift and double click to get into the new view, or I can right click the container and highlight the structure selection, hold shift and click, and I'm into the new view. This is just a preview, keep in mind. So now I can grab this knob and drag it and drop it. As well, I want to paste, right click paste from, oh no, I guess I lost my slider in my list. Okay, so we'll bring those back in, slider, our list entry and slider. These are the standard controls, whereas this is the subcontrol. So we see here this is pretty much exactly the same. However, we don't have the numeric readout, and the modules here are inside. So notice as well, this is from an older, this image must be from an older version of SynthEdit. We see that the GUI components are coming in on the left. As in here, they are coming in on the right. And it's locked. I gotta unlock it. So I'm gonna X that, right click, and go to more, and locked. So now it's unlocked. I can hold shift, double click to get in. And I'm going to grab all of these elements or modules, hold control and click the patch memory float to deselect it. And I'm going to move these to the right here. And I'm just going to grab these DSP modules, move them down with the bounding blocks. Now we can see more clearly that the modules are in fact connecting on the right, where the GUI elements have the connections on the left, opposed to this image here where everything is vice versa. How it works. 3 categories of subcontrols. The center point is the patch memory module. It handles the communication between the graphical elements on the left with the blue backgrounds, where in our case they're actually on the right with the blue backgrounds or the bluish-gray backgrounds, and the audio processing elements on the right with the gray backgrounds. So they are actually still on the right with the gray backgrounds. The patch memory module also handles any MIDI automation of the control and handles switching between the presets or patches. So that's here. If I click the patch memory module, patch memory float module, I can see under MIDI I have the MIDI assign amount piece, and we have a range and our current value, also a name. As well, we look at the text entry, for example, we don't see any MIDI or even any of these knob components. There's no MIDI automation. And the preset, or the preset or patch, has to be brought in using the patch browser in order for us to be able to switch between different patches or presets. So that's stored in the patch memory float. Without it, we wouldn't be able to store patches. Second type of module here are graphic controls, the bitmap image and the text entry boxes. These accept user input and display the control's current value. Graphical elements use the patch memory module as a hub. Input to any object is reflected back to others, keeping them always in sync. So our second type here is these graphic pieces here. And they are just visual elements here. I don't believe I can click that one. No, this is a background piece. The third type of module here is a data type conversion, for example, text to float module. Its purpose is to bridge the patch memory module's numeric float value with the text entry module, which otherwise would be used perhaps for entering a file name. So we can see that here the text to float, which is not present here. However, I'll bring one in. So I'm going into subcontrols and I want another text entry. So I'm just going to grab one from the list, text entry, drop that down here. And I'll pull it down a bit so it's more visible. Up. And I want a conversion module. So the conversion modules for subcontrols are under subcontrols. There are DSP conversion modules up here. So I want the subcontrol conversion modules. And I require the float to text. So let's grab that and drop that, and that's what it's mentioning, the third type. So in order to get a reading of the patch memory float, which is set to 9.95, I'm going to take the value and plug that into the left here under float value, and take the text value out into the text entry, and now it displays a 9.96. And the decimal places here is set to -1, which will display as many decimal places as needed. You can see there's 1 there now, and as we move through the values, we end up with 2. If I set this to 0, we have no decimal places. So it just goes steps from 1 to 10. However, if we look at the float and we are somewhere, say, between 7 and 8, it is actually still having a half number there, or 64ths. We turn the decimal places up to 1, and we have 1 decimal place up to 2. We have 2 decimal places, and we can just keep going. So we have 5 decimal places now. And back to -1. Keep in mind, there is no -2, -3, and -4. If you attempt to type those numbers in, I do believe SynthEdit will crash. So yes, keep that in mind. Do not type -2, 3, or 4. SynthEdit might crash. Back to the manual. Just going to check my microphone. I'm good. You can see from the arrowheads that graphic pins' blue backgrounds are bidirectional. This ties in with the expected behavior. Updating the numeric entry box moves the knob, and vice versa. The signals are not sampled like audio signals, but are event-driven. So the knob consumes CPU only when being moved, compared to an audio signal. The knob generates data at a much slower rate. So these are bidirectional, meaning that they're constantly feeding each other, specifically between the animation position here and the value amount, the value data. So what it's saying is, if I say 5 here, then the knob moves, or if I move the knob, then the numeric reader moves. Whereas the DSP out is only 1. It's only flowing out. So these are also only updating at 60 frames a second, or your screen rate. And the audio out is coming out at the whatever your sample rate is set to, likely 44,100 times a second. The signal leaves the patch memory module as an audio connection, but still at the slower rate generated by the PC's graphics system. The float to volts smooths and upsamples to a true audio rate signal suitable for driving SynthEdit's various audio modules. In SynthEdit, audio rate signals are called voltages because SynthEdit is simulating an old-school voltage-controlled synthesizer. The float to volts gives you control over how smooth the conversion should be. Less smoothing uses less CPU, but may sound stepped or zippered. So that's pretty much explains itself. Apparently, the data coming out here is actually only going at your screen rate, and then once it hits and converts into volts, it should be upsampled to 44,100. The general structure of a subcontrol patch is graphic control, data type converter, patch memory. So graphic control, bidirectional to data type converter, bidirectional to patch memory, and unidirectional to audio modules. Customizing. You can see that the numeric input is optional. Just delete it if you don't need it. Same with the rotating knob image. Also, you can now place the elements however you like, arrange everything horizontally, for example, by opening the knobs panel view and dragging the subcontrols. So looking at the panel view here, we have our text value, which is displaying here, text entry 3. And we have our other text entry, which is displaying the numerical value. And we can arrange them however we want now, just by clicking them and moving the bounding blocks. So I want this label on top, and I'm going to rename it up here with the text entry selected. I'm going to call that control, just to demonstrate naming. We also have a style under here, which is heading 3. This creates the transparent background. Text entry down here, style is normal. That's why it has a white background. So in panel, we have control, which is the transparent background, and we have the numeric entry, which has the white background. And we can resize our numeric entry if we want. Generally, it's best to keep it right to the maximum here, maximum size. So we have 4 digits. We also want something to be factored, so factors of even numbers. So 2, which would be 4, I believe, 4 pixels, 4, 8, 12, and 16 looks like enough. Now that should be exactly center. Or not, let's go 5, which would be 40, 15, 20, 20 pixels long, because I'm awesome at math. Alright, let's move this stuff over as well. And we have a centralized, everything's nice and centralized. We move this down so it's not covering the indicators or the shadow. And yeah, we can even put them horizontally or however. We can change the style here. We can go heading 3 if we want. Heading 3, just type that into style, and we have the same sort of transparentness here. And we can still click it and change it, and the knob responds. Alright, new pins in SynthEdit version 1.1. So Hint provides tooltips, the yellow pop-up box, the pop-up yellow boxes that appear when you mouse over the control. So I did attempt to demonstrate this in the rehearsal, and it crashed SynthEdit. So we're just going to bypass that for now. I'll come back to it. Got a lot to cover. Actually, I want to check my time. Not bad, 15 minutes. Menu items and menu selection provides a context menu, right-click menu. Type the menu items as comma-separated list. Example, set centered equals 1, randomize. This will appear on the context menu along with SynthEdit's menu entries. Menu selection pin outputs the user's selection as an integer. Example, if the user clicks set to center, then the pin goes to 1. After any selection, the pin returns quickly to 0. Always number your item list from 1, otherwise the first item will always output 0, which is no different from no selection. So that's a bit more of an advanced topic, menu items, menu selection to generate a right-click list. I'll cover that somewhere down the road. Grade disables the control so users can't change it. Use to indicate that control is not currently relevant. So I can demonstrate this. However, I'm going to add the right-click menu to my to-do list. So I'm just going to throw up a BRB and grab my to-do list and add that in there. Is my microphone? Yes, my microphone is still there. And I want SynthEdit documentation. Right-click menus, just so I know for later. Close that, and we'll come back to my desktop, which is this button. Yeah, okay. So quickly demonstrating grade. I'm just going to use this with a quick control. Controls are good for, you see, quickly doing things, making quick scratch ideas. So we're going to change this to a button, regular button. No, I want a small button. Small button, and I'm going to connect that. Oh no, I can't. Huh. Alright, so I can't really demonstrate grade with a sort of interactive ability. So I'm just going to turn it on. I'm going to open up panel edit here. And I'm going to make some space so I can see both of them at the same time. And say if you had a trigger and you wanted to disable a control, it doesn't actually disable a control, you have to do all that routing yourself. However, visually, if you use the grade option here and you click it, and then it changes the color of the text to gray. And we can do that for this one as well, just to demonstrate. So both at the same time, it looks like the knob is, not applicable or relevant. Efficiency. Modules with blue backgrounds are GUI modules, graphic user interface modules. These are designed to process user input, most clicks and text entry, etc. They are not intended to process audio signals. On multi-core systems, they will usually run on a core separate from the audio processing. This allows the audio modules to take priority when the CPU is under load. I need 1 second. Modules with both blue and gray pins, like the patch memory module, are hybrid modules. Internally, they consist of two parts running simultaneously in separate processes. Communication between the two parts is complex and more CPU intensive than between other modules. Don't use audio modules to process GUI signals. In general, aim to minimize your use of hybrid modules. For example, suppose you want to increase a knob's display to range between 0 and 100. You might think to use a standard multiplier module. Being an audio module, this requires an extra conversion via patch memory or similar. Much better to use a pure GUI solution like the float scaler module. This will keep your circuits simpler and your CPU far lower. So here we have a picture of an image coming into a patch memory float, going out to a float to volts, going out to an IO mod. And we also have a times 100 mod, or a multiplication module from math, which is here. I think it's just named. So on SynthEdit, we have a math section here, and that's multiply. So it times 100, I believe that's just changing the title. I'm going to multiply with times 100. And they look sort of similar. This is the older version, but that's how it would look. So it says wasteful audio processing. And then after that, it comes into a volts to float, and then a patch memory float out. So this is where the DSP is coming in on the left and programming a GUI, and then a float to text, and then into a text memory or text entry. So yeah, it's running through the DSP. So it's coming out at, let's say, 60 frames a second or 60 hertz. And then when it comes into the float to volts and then coming out here, it's now running at 44,100 times, and then going into this volt to float, and then volts to float, and then into this patch memory out. So after it converts back to 60, the 60 frames per second, and is coming through this float to text and then into the text memory. So we don't need to have this conversion happening like this. This is wasteful because this part here is running at 44,100. We can do it instead. Does it demonstrate? No, it doesn't demonstrate. We can do that instead. I will demonstrate with a, say we wanted the readout to read, this times 100 can go, that's not part of the demonstration. So we wanted this readout to read something else, the times 100. So we're going to go into subcontrols, and we're going to go into conversion, and I believe float scaler is here. This is float scaler 2, which I believe has been updated to be more efficient. So we're going to take this, we're going to break this connection here by clicking the line and hitting delete. Additionally, that can be done by clicking a line, right-clicking the line, and delete line. So we're going to go from the patch memory float value out into the value in here on the float scaler, and value out into float to text here. And currently we have multiply by 1 or add. So we wanted to multiply by that by 100. So we're going to go multiply by 100. Now we have 500 down here. And as we move our knob, it's going to continue to change that number. Now this is better than, actually let me get rid of this decimal place right quick. This is better than the design here as it's running through the DSP. As now that it's all consistently GUI, these are all only running at 60 hertz or the frame rate, instead of running through a 44,100 and then back into 60. So that's what that's saying. Use custom with GUI connections into containers. SynthEdit 1.1 uses a new subcontrol system. The new subcontrols are only active when the control panel window is open. When you close a control panel, the subcontrols become inactive. Also, GUI pins communicate only with modules visible in the same window. The behavior is to support the new VST standard. Example: knob image inside a container connected to patch memory outside the container. The knob does not respond to mouse movements and appears to be frozen. Alright, so let's take a look at that. So if I have this patch memory float and I go more containerized selection and a little bit of a sing voice there, now now it's not gonna work, because these controls can't see inside the container, and that's a GUI thing. Alright, I'm gonna right click that and uncontainerize it. It is, let me look here. It's usually only the structure view that experiences the issue. If the NOS container has controls on parent set, it'll work fine in the panel view. The reason is, with controls on parent set, the knob displayed on its parent container's window, the same container the patch memory is in. This can be confusing, so if possible, confine your GUI connections within the same container. Okay, so apparently if I containerize this and it no longer responds, it will still respond on the panel by right-clicking panel. Okay, let's see. Nope. If you need GUI connections into a container, you can often get the structure view working too. Here the container show on module is set. This makes the knob too visible in the same window as the patch memory, so the connection works okay. Grammar. So if I click this container that the patch memory is in and go controls, I had to put controls on parent, okay, for the, yeah, okay, now it works, but it's not working in here. And if I go controls on module, see, it's not working in here, and I click controls on module, now it should work. Yeah, let's see, down here it's responding. So yes, avoid this situation if you actually absolutely have to. This is actually something I do just to separate GUI elements and the patch memories. You need to have controls on module for it to work inside the structure environment, and controls on parent for things to communicate between containers. Subcontrol or patch memories to subcontrol visuals here in the panel. So subcontrols on parent here, subcontrols on module here. With both of them off, it's not going to work. Note, the right-hand Windows knob still won't work properly. It's a subcontainer. There's no way to get the patch memory module visible in that window. Summary: subcontrols in a container will work fine on the panel view provided the container has show on parent set. They may not always respond on the structure view, but you can often fix the problem with show on module. So I just said that. And I don't have my chat up. Well, someone's chatting to me. GUI modules need to be seen. Subcontrol function. I need to get that chat out of the way. Subcontrols function only when their container's panel is open. I.e., if you choose your synth panel, those subcontrols become inactive. Or if you close your synth panel, the subcontrols become active. Therefore, never rely on GUI modules to process audio signals. The exception is hybrid modules, or patch memories, which continue to provide patch selection and automation functions via their audio pins. So yes, that means that do not run DSP through GUI. Pretty much the backwards of this scenario. So if you had, for example, it's going to be a little difficult to demonstrate, however, if I had waveform oscillator, and this oscillator is sending data out or audio out, and I took it and put it in say a float out, and then I took this value here, a conversion, and say I wanted to make it, I don't know, I wanted to change it, I wanted to modulate it somehow using this not float function, but the float scalar, which is easier to understand here. So we're going to take that and put that into value in, and I added, 5. I'm not sure what that would actually do. It would kind of probably skew the waveform. And then I took the patch memory float here, I do believe we're going to use patch memory float. Do we need it out again? So how do I get this to DSP? That's what I mean, it's a little complicated. Okay, well, see, I had that like that. And let's say that we had the value actually an add. So this is a patch memory float, and I'm going to bring in an image just to demonstrate this properly. And I got this little knob guy here, and I'm going to plug this into animation position. And this is now controlling this patch memory float, which is programming the add. So when I move the knob, it's going to change the value here. So we're going to put that back to 5. Now, how do I get this out to audio again? The float value out won't do it. No, I don't think there's actually any way. Interesting. So that was a botched example. However, if I did manage to get it to output to audio, any control here would be not changing this, or it would only be changing it at 60 frames a second. So it would, reduce the amount of times I'm scaling. If it was automated, like it was automated, and I used this, and if it was closed, if the GUI was closed, it wouldn't respond. It's a nightmare. Avoid that situation where this is reversed. Audio splitters. Due to a design mistake, SynthEdit 1.0 had the container's control on parent pin on the wrong side. This made it impossible to connect it to a patch memory module needed for save recall of page panel settings. The bool split was introduced to fix this problem, but the bool splitter causes problems of its own. The bool splitter reflects any one input signal back to its other inputs. This is a bad design because it's not clear which module is in the control of the others. The result is modules fighting each other for control. Symptoms include flaky, inconsistent behavior and patches not saved, recalled correctly. Third-party module developers have sometimes copied SynthEdit's examples and released modules that rely on use of splitters. This is not their fault, however. If at all possible, avoid using splitters. So yes, the splitters idea. I'm not sure if I mentioned this earlier, that you cannot have, I'm going to uncontainerize this here, you cannot have two floats controlling one knob. That's not entirely true. We can bring in a float splitter under the old. So subcontrols old float splitter. And what's going to happen here is value goes into one end from one float memory and value from the other end to the other float memory. And then if I take that and I put it, I'm going to get rid of this scalar, and I take this output of this splitter and plug it into the float to text, into the text entry. I now have this one knob controlling two float patch memories, which is redundant. And say if I had something else happening, like another knob or another, let's just say another knob for simplicity, an animation position. Now, if I control one, I'm also controlling these other ones. I mean, it might seem like an okay idea, but now they're fighting for control. Like, who's winning here? It's inefficient. There's other ways to get things done. However, in ultimate last-ditch scenario, float splitters do come in handy, but they're dangerous because they will infect the whole chain. Anything you connect to a float splitter will override everything. So be careful with splitters, definitely. It's a big one. Prefabs worth studying. SynthEdit's Insert Controls menu has several good examples. The joystick module shows how to make any type of horizontal slider, vertical slider, two-axis. Let me get rid of my helper. From the left, SynthEdit's Insert Controls menu has several good examples. The joystick module shows how to make any type of horizontal slider, vertical slider, or two-axis joystick. Hint: for sliders, use the resize handles to restrict the area of the movement to a narrow strip. The LED2 prefab is a template for any type of indicator or meter. Notably, it is clever use of transparent overlay image to dim the light, and use of tinted image module to provide for any color light. Further reading: David Hapt's Intro to Subcontrols webpage and the book Visual VSTi Programming from Wazoo Books. So I didn't know there was a intro. Oh yeah, Intro to Subcontrols. Okay, so it's just a webpage. David, yeah, did contribute to the Wazoo book here. Perhaps I'll look at that down the road. So that's it for subcontrols. What was it? Prefabs we're studying. Okay, so we can take a quick peek at these. These are the two prefabs it's talking about here. I'm just going to move down. I do believe they are under examples. So we have under examples, page panel, radio buttons. What did I say it was? Oh, they're prefabs. That's right. All right, so that'll have to be a discussion for a different time. So yes, that ends subcontrols. And that pretty much as well ends my stream. Nobody's talking at me. Well, it doesn't end my stream. I'm going to continue into an advanced topic, and that will be available on my Patreon, which is a link should be in the description. And yes, advanced intermediate topics will be posted to Twitch and will be available there. They will not be available publicly on YouTube. They will be available on Patreon, at least the link to them. So I'm going to close this down, and yes, that's the end of the subcontrols demonstration. So I now need a new title card. So this will be called this is going to be called wait a second. Extended. I can spell. Extended? Oh, that looks so wrong. I need to look it up. My brain is not happy right now. After all that reading. Yeah, that's right, extended. Extended GUI. No. start with GUI. GUI extended nested panels.